Okay, hi guys. I am here today with my first science demo video. We are talking about chemical reactions, and specifically today we're going to talk about what happens to the atoms in chemical reactions, what happens to the bonds. And so to do that, I'm going to do a little introductory activity for you using some fruit, okay? And basically what we're going to do is take the idea behind my fruit example, and then we're going to apply it to an actual chemistry example, okay? So, yeah. Okay, so I want you guys to look at my fruit example here. All right, on the left side of my towel, I have 1 avocado and 4 grapes. All right, and on my right side, obviously, I have 4 strawberries. Okay, so total of 1 avocado, 4 grapes, and 4 strawberries. Now, I'm gonna do a little bit of rearranging. Okay, now look at what we have here. Actually, I'm gonna move these down here. Okay, on the right side here, I have my 4 grapes. I have 2 strawberries. And over here on the right side, I have my 1 avocado and 2 strawberries, okay? Now, thinking about the total number of fruits that I have here, I still have 4 grapes, I have 4 strawberries, oops, that's strawberry, and 1 avocado, right? They're in different groups now, they're in different pairings, but I haven't lost any and I haven't gained any. I still have the 4 grapes, the 4 strawberries, and the 1 avocado. Okay, so keep that in mind as we move into our next part. Okay, so the next part of this demo, I have a cute little candle here, and I'm going to light it on fire, hopefully, or light it. I'm not good at using these things. Oh, first try. Okay. I'm gonna let it sit there for a second. First things first, I want you to think about physical changes versus chemical changes. We took notes on this yesterday. Okay, we learned about physical changes in our chapter when we did changes in states of matter from a solid to a liquid to a gas, okay? In physical changes, we have the atoms, they're slowing up, they're speeding down, okay? They are changing forms, but the key here is that a new substance is not created. When water freezes, you can take that frozen water and get it right back into its liquid form. Okay, so we would call that a physical change. In a chemical change, the key here is that a new substance is being formed. Okay, a new substance is being formed, and this happens through something called a chemical reaction. So, if we go to our candle here, the candle is lit, all right? In chemical reactions, we have something called reactants and we have something called products. You're gonna take notes on this today. Reactants are 2 or more substances that can form what we call a product, okay? A product is simply just the outcome, you could say, of a chemical reaction, okay? So, when we think about this candle here, what do we think the reactants are? The things that are reacting together to create something else. Now this might be a tough question, okay? I'm not expecting you to know this answer, all right? Well, what components do we have here? We have the candle. The candle's made of wax. We have what we call the wick. That's the little part that sticks up that kind of looks like that's what's on fire. We have the flame. Is there anything else that we might have that we can't really see? Hopefully you're thinking of the air surrounding the candle, and that air is made out of oxygen, right? So the 2 reactants that we have here are actually the wax and the oxygen, okay? Wax is, in very simple terms, it's called a hydrocarbon, which means it's made of hydrogen atoms and carbon atoms, okay? And then we have the oxygen that is surrounding the candle. So this is kind of a common misconception or a common idea that's actually wrong, is that like the flame is one of the reactants, and that's not exactly true. That's like a different thing. If you want to know more about that, email me or something and I can give you an explanation. But yeah, we have the wax, which is made of carbons and hydrogens and oxygen surrounding the candle. So what do you think is gonna happen if I put this glass cup over the candle? You can probably guess that the expected outcome would be for the candle to, what's it called, like burn out, I guess. So I'm gonna put my goggles, aka my glasses, on here. Okay. Still going. All right, and now it's out. So, what happened? Okay, yes, the flame went out, but chemically, we want to think about this in terms of a chemical reaction. A chemical reaction takes both parts, okay, at least two, it can be more. We're gonna go simple though and just say two. It takes both parts to be reacting with one another in order for the reaction to happen. So, what reactant, the wax or the oxygen, was cut off? It was the oxygen, right? This glass jar cut our supply off. So there is still oxygen inside the glass, but really like not enough to keep reacting with the wax. Okay, now what happens is a product is created, or products are created from your reactants. Here, in this specific example, the two reactants that are created are carbon dioxide, or I'm sorry, the two products that are created are carbon dioxide and water. Okay, so what is happening chemically in our candle example, right? I mentioned earlier that the wax of a candle is something called a hydrocarbon, okay? Wax is made of this long molecule called paraffin, and paraffin is a hydrocarbon. It means it's made of hydrogen and carbon atoms. We're gonna use the most simple form of a hydrocarbon today, CH4. Okay, another name for this is methane, but it contains one carbon atom and 4 hydrogen atoms. And then we also had 2 oxygen molecules, okay? So remember, an oxygen molecule is, well, you probably don't remember this, but I'm gonna tell you. An oxygen molecule is made of 2 oxygen atoms, and we have 2 of those molecules. So in total, we actually have 4 oxygen atoms. All right, so I'm gonna do a little drawing here. Okay, so 3 colors here. Anywhere I draw a blue circle, that's going to represent a hydrogen atom. A red circle represents an oxygen atom, and a black circle represents a carbon atom. Okay, so if we take our first molecule here, the CH4, we have 1 carbon atom and 4 hydrogen atoms. Okay. And then we have 2 oxygen molecules. So there's 1. It's made of 2 oxygen atoms. And then there's the other. Okay? So notice here we have 1 carbon atom, 4 hydrogens, sorry if this is too small, you guys, and 4 oxygen. Okay, now remember in the last part I told you that the products of our candle example here are carbon dioxide, CO2, and water, H2O. Okay, now you don't have to quite understand the numbers of this yet, but I do want you to visually see something that I'm gonna explain actually after I draw it. So if we want to go ahead and draw our carbon dioxide and our oxygen, we would do it like so. We have one carbon atom, two oxygen atoms, and then we have, sorry guys. Then we have one H2O, so we have our oxygen and two hydrogens, and our oxygen and two hydrogens. Now, let's count the total number of each of the atoms. On this side of the equation, how many carbon atoms do we have? How many black circles? We have one. How many hydrogen atoms do we have? 1, 2, 3, 4. And how many, can't see this here. How many oxygen atoms do we have? We have 4. Okay. Now, what do you notice about the number of each, type of atom between the reactants and the products? They stayed the same, right? We still have one carbon before and after. We have 4 hydrogen before and after, and we have 4 oxygen before and after. Now, think about the fruit example that I gave, right? We started with 1 avocado and 4 grapes together, and then a group of strawberries and another group of strawberries, okay? This feels kind of awkward, you can't even see the grapes, okay? Then I redid the groups. So then we had a group of 1 strawberry and 2 grapes, 1 strawberry and 2 grapes, and then the avocado with 2 strawberries. Okay, I think the strawberry just flicked somewhere. I know you can't really see this very well, but our total number of fruit still stayed the same, right? I didn't take any away, I didn't add any. We still have 4 strawberries, 4 grapes, and 1 avocado. We just arranged them differently. Now, I'm gonna tie this all together. In chemical reactions, we're not gaining or losing any atoms, okay? What's happening is that the atoms are being rearranged, okay? They're being rearranged. If you look on slide 13 that you're gonna take today, okay? This is what I'm about to say is basically the notes for today, all right? That chemical bonds that are between atoms, when the particles in the atom are colliding together with enough energy, the chemical bonds can break apart between the atoms, and the atoms will rearrange themselves and essentially rebond, but in a different way, okay? And the atoms rearranging and rebonding is what creates the new substance, which is what we talked about at the very beginning of this video. A chemical change shows some type of new substance, right? It's kind of like a permanent change. Whereas like water, I could freeze it and turn it into ice, but then I could get that ice right back into water. In chemical changes, that's not true. There's a new substance or substances form, and it's more permanent, okay? And that's because the atoms have actually, the bonds between the atoms have actually broken apart, the atoms have rearranged and then rebonded in a different way. But the number of atoms at the beginning and at the end are still always going to be the same, okay? So I want you to go ahead and read the rest of the Google Classroom assignment for today. Take the notes that you need to take, email me with questions, and yes, I will talk to you guys soon.